So as I was just saying, we're going to solve that problem type. I don't know what problem type number it is on your little list there, but you'll certainly identify it with the picture. So here's kind of a neat little thing here. You can see my, I don't know, we should have guns in school, but just a simulation here, right? So okay, so that's kind of neat. But what I'm really talking about here is this kind of thing, right? And as I increase the speed, where's my speed? Do I have a speed? I guess I don't. Okay, this letter, position the gun, click the knob, change the angle. I guess I don't have the speed. Oh well. It is a problem, right? What would you say the vertical displacement is? Vertical displacement. 0. Is that key? Is that important? Absolutely, right? And I guess you can treat the thing as sort of like two, you can think of it as the upwards part and the downwards part. And then let's say it goes up to about, I don't know, what would that be, about 20 meters, right? So the upward part would be a displacement of plus 20, and the downward displacement would be minus 20 with an overall displacement of 0. So that might be helpful to us as well, right? I wish I could, well, there's the initial velocity right there, 31.3. That's an odd number. Guess I can't adjust that. Very odd. Okay. Oh, let's get some clickers in. Okay, so the question is, considering a projectile launched at some angle, some unknown angle, true or false, the vertical acceleration remains the same throughout. And again, I know that I'm repeating myself quite a bit here. The vertical acceleration remains the same throughout. True or false? So you have a T or F button on your clicker. Yay, that was quick. And the answer, of course, is true. What is that vertical acceleration? Minus 9.8 meters per second squared. Watch for the word vertical. True or false? The horizontal velocity remains the same throughout. I know I've repeated myself. Some of you are probably tired of me repeating this. But I'm not stopping until I see 100%. And even then I might continue. The horizontal velocity remains the same throughout. True or false? And the correct answer is true. Uh-oh, that didn't look good. Horizontal velocity. What about the horizontal acceleration? Does it stay the same too?
Well, yeah,
it's 0. Absolutely, it stays the same. The horizontal velocity stays the same. The vertical acceleration stays the same. What about the vertical velocity? Does it change?
Yes.
It changes. Okay, well, here's sample question number 2. The ball is hit at an angle of 30 degrees and leaves the bat with a velocity of 40 meters per second. We would say that the launch speed, or if it's a gun, we would use the term muzzle velocity, but it means the same thing. The launch speed is 40 meters per second, and the angle is 30 degrees. So again, here we're hitting that outcome about finding components. Are you always going to have to find components with these? Like, is every question going to start with finding components? Yeah, pretty much. I can't imagine how you couldn't, right? So find your VV, find your VH. One of them might be 0, but you still sort of should identify them at the very least. There's mine.
What really is trig?
For me? It's just basic trig, exactly. That's all it is. It's what, grade 9 or grade 10 now? I think it's grade 10. Is there, I don't, oh, is that a question? I don't think it is. Or is it? Oh, it is. Yay. I didn't even realize that it was. We're looking for the vertical component using sine, cos, or tan. And we are waiting for Dallas. He's got the wrong device in his hand to enter it. Wouldn't that be cool if your calculator could send the message to, but it can't. And you have to probably, is there a decimal in there? What'd you get for an answer? 20? Lots of people did. How do you find it? 40 sine 30. Right? 40 sine 30. Why is it sine? Because it's opposite. VV, VH. Gee, what do you think question number 4 is going to be? I was right. It is find VH. Wow. That's amazing. Find VH. 34.6. 34.6. Yay, almost everyone got it. How do you find it? 40 cos 30. I'm going to guess the one person got it wrong put 34.5. Well, there you go. I guess I should put here in my question. Remind me to do that too. Change the question so it says 1 decimal point. Okay. What about time of rise? I'm going to give you a hint. Time of rise, I'm going to use VF equals VI plus AT, but which V do I use? Do I use the 40? Do I use the 34.6? Do I use the 20? Or do I use minus 9.8? Which one of those do I use? Yes, the correct answer is C, 20. Uh-oh, I better teach this, I guess. How come it's 20? Because which one am I going to be needing? It's rising. What's the velocity that contributes towards the rising? The vertical velocity. The vertical component is the one that tells me how high it goes. The 40 sort of gives us or produces the 20, but the 40 is horizontal plus vertical, but it's only the vertical that causes it to go up. So the correct answer here is 20. So that's good that we've actually sort of spotted that mistake and hopefully we've solved it. So then, how do you actually solve for it? Well, it's just 20 plus minus 9.8t. And I'm hoping someone will ask, does the sign matter there? Do I have to use negative 9.8? Why do we have to? Yeah, when 20 goes to the side, it becomes negative. If you don't use minus 9.8, well, then you're going to get a negative time, right? Time has to be positive moving forward.
Will VI always be VB?
If you're asked to find time of rise, I really have to be, you got to be careful with the word always, because as soon as I say always, then someone's going to hold me to it, and then there's going to be some exception, and I'm going to be in trouble. I don't like saying always.
So is there a question that you have to use VI as horizontal?
I can't imagine one, but having said that, that doesn't mean that I haven't seen, that there isn't one out there somewhere, right? I mean, there might be one that has wind resistance where the could happen, right? Because we're dealing with time of rise, we have to use the vertical component. We have to use minus 9.8 because that's the acceleration. Okay, what about height of rise? Again, which vertical velocity do we deal with when we do height of rise? Apparently there's no question. Vertical component. So there's two ways to do this. You could either go Vf squared equals Vi squared plus 2At, like so. Notice that it's positive 20 and minus 9.8 to 20.4 meters. Or I could also use my time, and go something like that. And you'll notice that it's exactly the same number. Is that surprising? Shouldn't be. It might be off by a little bit, decimal kind of thing, but for the most part it should be the same. Notice that because we're talking about height of rise, we use the vertical initial velocity of 20. Same thing here. Does that make sense? I'll pause for a second. If I ask you for time of fall, well, the fall is from the top down, right? So it's the time it takes to drop 20.4 meters. How do I know that it goes up 20, or how do I know that it's dropping 20.4 meters? Well, because that's how high we calculated the height of rise was, right? What do you think it's going to be? No big surprise, it's going to be 2.04. Notice here that the displacement is minus 20.4. Why minus? because it's dropping. And what do you know? The time up is equal to the time down. Is that surprising? It shouldn't be. Now, that's not entirely true when there's air resistance, but for the most part, it's pretty true. Okay, let's talk about time of flight. Well, you should already know that, I think it's likely going to be here, right? If it takes 2.04 seconds to go up, it's going to take 2.40 seconds to come down, so the total time should be 4.08, right? That's probably the easiest way to do it. But is there a more elegant sort of mathematical way to do it? Well, it looks like it because I've got something hidden by fine print there, doesn't it, right? And you might say, well, why are you even bothering with that, Mr. Bennett? Well, it's because the point is that when we get to these type of problems, is the time up going to equal the time down? No, it isn't, right? So I'm sort of planting the seeds for that tomorrow. So I'll just sit back and enjoy the ride a little bit. So, would you agree, whoops, move some stuff out of the way here so I can make it bigger. Would you agree that the overall displacement is 0? Right? So my displacement is 0. My initial velocity is 20. Why do I use 20? Well, this is vertical displacement, so this has to be vertical velocity. 1/2 minus 9.8 vertical acceleration. And what do I end up with? 4.9 t squared minus 20t equals 0. Quadratic. Pause for celebration. As I expected, not a celebration. Now, you may have realized that you could do what? You could actually go, remember how to factor? 4.9t minus 20 is equal to 0. Remember doing that? Was that grade 11? Factoring? Grade 12 maybe? I don't know. It's been a long time, right? So it either would be t is equal to 0 or 4.9t minus 20 is equal to 0, and t would be simply 20 over 4.9. So you're telling me there's two answers, t is equal to 0? Yeah, I am. How come? Because the displacement is 0 at 2 times. The first one, right there at t is equal to 0. Right? Before it's been launched, it has a displacement of 0. It's kind of a moot point, but it's true. And then the other one is right there. So you could do it by factoring, or you could, because you're a math fanatic, a fan of math, you could use the quadratic formula. That didn't sound like a celebration. Yeah, you could do it like that if you wanted. No? Or you could, I was watching a rerun of Big Bang last night. The guys were working on an app that when you point your smartphone at an equation, differential equation, mind you, it's calculated, right? You press the app, and take a picture of it, and then it solves it for you. You could do that, I guess. No. Not that I'm aware of. Maybe it does exist. I don't know. I don't. But anyways, so of all those 3 solutions, which one are you going to choose? Likely that one, right? Yeah, of course. But please remember that that's not going to work when the time up does not equal the time down, and so you're going to have to go this route here. I'm sure you're anxiously awaiting that day. Can we just leave that there for a second, or? And the last question is almost always the range. What does the range refer to? Horizontal distance. How far away does it go? So how far is this baseball being, or whatever it is a baseball, I think, being launched at, right? So the range, remember that the horizontal velocity is a constant 34.6. Where do we get that from? Way back at the start here. VH, 34.6. How am I going to find it? Which formula? Because it's constant, I can use V equals D over T, 141 meters. That's pretty straightforward, isn't it? I apologize, one more question. What is the velocity and impact?
This is a question for...
I see that, yeah. And that question is, will the final velocity, before we solve it, will the final velocity be different from the original launch velocity? What was it originally launched at? I think it was 40 meters per second, and the angle was 30, I think, right? So what do you think? Will the final velocity be different from the original launch velocity, which was 40 meters per second at 30 degrees, and we would say above the horizontal, I guess, right? ATH, above the horizontal. Do you want to answer now, or do you want to wait and get it right? What do you think? Go ahead and answer now. Will the final velocity be any different than the original launch velocity? Will it land at a greater or lesser speed than it was originally launched? Did you press the wrong one? Now you want to change your mind? Because I said it differently or something? Will it be different? No, it will be the same. I will prove it to you. V is the vector sum of VH and VV. Well, VH is 34.6. What's the VV? Well, it's the final velocity for an object falling for 4.08 seconds. Hold the phone there for a second. I thought it only fell for, all the way down, 2.04 seconds. Is it falling as it's going up? Well, in a physics sense, it sort of is, right? It's falling from below where it would be if there was no gravity. Okay? So I just want to point this out here, because the math is kind of interesting. If you put an initial velocity of 20 in there, positive 20, and the total time, you're going to get minus 19.98, which is, for all intents and purposes, minus 20. If I put an initial velocity of 0 in there, and I use a time of 2.04, what am I going to get? I'm going to get the same thing. Okay? And then what? Well, then, draw your picture, like so. Oh, I've got so many things here I can hardly see what they are. So this is going to be 34.6. This one's going to be minus 19.98. So do I have it here, maybe? There we go. 34.6 squared plus 19.98 squared. 39.96 meters per second, which is, for all intents and purposes, 40. What about the angle? We're talking about this angle right there. What's it going to be? 30 degrees below horizontal. Okay, so technically the velocity is technically different. Is that what you were talking about, maybe? Because the angle is different. So maybe, okay, if you said yes, and that was your argument, I'll accept that. Anybody say that? Yes? That was your thought? I'll trust you on that. So yes, note that the final velocity is equal to the initial velocity, with the exception of the below the horizon and the above the horizon, right? Now, normally I would say something like, well, you know, it's not really rocket science, but in this case, it sort of is. I knew a guy in university once. He was actually a rocket scientist.
What is a rocket scientist?
He studied rockets. Like, he was an engineer. He built rockets. It was a neat thing to pull out at parties, right? So what do you think? I'm a rocket scientist. Oh, yeah, good one. No, I really am. Rocket scientist. I don't know. You've got a new package of problems there. Again, they are assorted. So please sort of, I see people writing here, so I'm going to stop. Wait. Okay, so again, you've got a new package here, and as I was just saying, they are assorted. I would encourage you to write down the number of the type. Was that on that list of questions, or list of that course outline? Did I number those problem types? I think they were numbered, weren't they? Okay, so just use those numbers to sort of identify them. Again, make sure that you can solve every type. What type is this? Okay, let me get those right there. No? Like the course, the units are outlined. That one right there, yes. So this is actually number 2, horizontal ground at angle. So the sample we did today was number 2, right? But for example, the very first one is off a cliff, so that would be number 6, and so on. Right? Number 2 is also number 6. So it looks like 3, so it's 4, so it's 5, lots of number 6s. Okay, number 6 is a field with throwing a ball, so that's very similar to this one here. And so on, okay? You'll notice that the very last question, number 14, is being projected off a cliff. Don't even attempt that one just yet. That'll be saved for tomorrow. At one time, all of these questions had to use, because these were so old that gravity was actually -10 back when these problems were first devised. I think they were 10 because that was back when, I don't know, I had a teacher once that just used 10 for his gravity because that way you didn't have to multiply by 9.8, you just multiply it there. I need a calculator for the next step, it's a big deal. Anyways, all of my answers were originally gravity -10, and you'll notice on the back page here, special thanks to, and I'm by law obligated to mention this now, special thanks to Tyler Latane, Tyler Ranson, and Ryan Bjornson, because I told them they would get their names on here if they did all the answers in -9.8, and so they did that, and then I was forced to put their name on there. So. And they bought it in for me. So your answers are provided by those 3 gentlemen today. All right, I'll be quiet for a while. Enjoy.